Okay everyone, so now we are learning the structure. To understand the structure, I am taking the example here. Let us suppose that we have declared one variable c. So here int c, that means a variable c is declared. We know that int is a type or the data type which store integer values. Let's say we are having the value, first value is 101 we can store, or we can store 102. So we know that only integer values we can store here. Let us suppose that we have taken one more variable, so that is char g, means a variable g is declared of character type. Character is a data type. Now here we know that, let us suppose that here I am saying a, so this is one character. Character will be having a single quote, or maybe we are having v, so this is one character. So character can store only characters. Now I am a user. Let us suppose I want there should be one data type in which we can store character as well as integer. Let us assume that it is my wish that there should be a data type where I should store 101 as well as a. So this is how we can combine the multiple data types. So here what I am doing, I am putting these two data types into the curly bracket, and above that I am using a keyword that is named struct. So struct is a keyword to define the structure. Now let us suppose that the name of structure I am providing here is employee. So this is how we can create the structure. So here we can understand one thing, a structure can contain different data types, or we can say that structure is the collection of different data types which are grouped together with a single name. So here we are having the definition that different data type. Here we can see that int c, so here it is an integer data type. Char g, g is the character data type. They are the different data types, and they are together inside a single name. So the single name is employee. So inside the employee we are having is the integer c and character g. So different data types in a single name is called the structure. What is the purpose of structure? Let us suppose that I want to store, let's say employee code, let's say 102, and employee, let's say grade, which is, let's say V is some grade. So here, this is how we can store the record. Maybe there is an employee code 101 and it is having the grade A. There is an employee which is 102 which is having the grade V. So this is how we can store the records. Means whenever you want, there should be different data types stored together. This is called the structure. We know that this is my wish that I am storing one character and one integer together. So that means it is the user wish. So user is defining. That's why it is called user defined data type. Means it is totally up to the user which data type it wants. Let us suppose that inside the structure, I want that there should be one integer and one character. So that is my wish. So this is the user defined data type. For defining the structure, we use a keyword which is called struct. So for the structure, we use struct keyword. Now we are learning the definition. Definition means defining the structure. For defining the structure, we are having the syntax. So here we are having the syntax of the structure. Now, to define the structure, first of all, we are using the keyword that is called struct. So I am taking the example here. First of all, we are using the keyword that is struct. So that is giving the compiler indication that we are going to define a structure. Afterward, structure name. Let us suppose that the name of structure I am providing is the employee. After that, we are having the body of the structure. So here we are having the curly bracket start. Inside that we are having type. Type means data type. Let us suppose that the first type I am using is the integer. So integer is data type. Then variable 1. Let's assume that the first variable I am taking is the C. So here C stands for code. So here C is the employee code. Then afterward is the type. So here I am using, let's say, the other type which is char. So char is the character data type. Then variable 2. So variable 2 I am using, let's say, G. G stands for it is the grade of the employee. Now I can define multiple variables here, but I am taking only 2. Then afterward closing bracket. So here bracket close. Most important, semicolon should be provided at the end. So this is the definition of structure. From the definition, there are few things to learn. We are using the struct here. This struct is called the keyword. Keyword means it is the reserved word. Nobody can use this keyword unnecessarily. So here I am using it. That means I am giving an indication to the compiler that I am going to define the structure. Afterward, we are having is the employee. Here employee is the structure name, or we can say that it is the tag. You can say it's structure name, tag, or the tag name. All are the same thing. After that, we are having is the int c and char g. So these two are called the elements or the members of structure. So this whole thing which we have created, struct employee, then afterward bracket start, int c, char g, bracket close, and semicolon. So this complete thing is called the structure definition, or the format, or the template. The format or the template signify that any of the variable we are taking of structure, that will be following this template or the format. So now we are learning the declaration, or we can say that declaring the structure variable. For declaring the structure variable, we are having the syntax. To understand that, I am taking the example here. We know that whenever we are declaring a variable, we first of all say its type. We say that int. We know that int is the system defined data type. So here this int definition is already present into the system. So this is the system defined data type. Similarly, we know that structure is the user defined data type. So here we have created the structure, and we know that the name we have mentioned is the employee. So here the complete name will be taken. Here we will take struct, then afterward employee. So here this complete is acting as a user defined data type. So the format says that first of all we have to use the keyword, that is struct. So whenever we are using the user defined data type structure, first of all we will write here struct. Now struct signified is a structure. Now afterwards structure name, we know that the name of structure we have taken is the employee. So here we are writing that is employee. So that struct employee, this is the user defined data type. So whenever we are using this struct employee, you should understand that this is the user defined data type. So whenever we are declaring a normal variable, let's say we are saying int a. So here a variable is declared of integer type. Similarly, in the user defined data type structure, we can declare its variable. So here we can say that struct employee a. So here a is the variable. So we can see that struct structure name. So this is the user defined data type, and variable name. So variable name we have taken is the a. Whenever we are declaring a normal variable just like int a, we know that here a memory block is reserved, and here the name will be a, and there will be some address. We are assuming, let's say 301. So here a memory block is reserved. That is called declaration of a variable. Similarly, when we are going to declare a variable of the structure, just like a we have declared, so what is going to happen? We know that it is struct employee, means employee variable or the object is created. And what is the employee? Employee is a structure, and structure contain its body which is having two members. That means a, corresponding to a, there will be two blocks that will be reserved. So here a will be having two blocks because that is a part of structure. So here the first part will be c. So that c is what? It is nothing but the int c. That means it is having some address, let's say 401. And second block will be reserved. We know that that is g. So corresponding to a, we will be having one more block, that will be g. And g is what? This is the character. And let's say the address is 501. So whenever you talk about a, now a is having two blocks. So here corresponding to this variable a, we will be having the two blocks created. Why? Because this a is the variable of employee, and employee is a structure, and structure contain 2 further elements. So whenever you are creating a variable of the structure, at that time correspondingly whatever the elements are there, that much memory will be reserved. So if somebody asks you, whenever you are creating the object or the variable of a structure, how much size the structure will take? We know that whenever we are taking a normal variable, just like we are using int a, at that time only 2 bytes are reserved, because we know that int consume 2 bytes. So at that time 2 byte of memory is reserved. But whenever you are dealing with a structure, what is the size of this structure? So if somebody asks you what is the size of this structure, the size of structure is sum of the size of its elements. Structure contains 2 elements. The first element is int c. So here we know that the size of int is 2 byte. So here we are taking the 2 byte. Then afterward is the char g. We know that character take 1 byte. So here the elements of the structure are of 2 byte and 1 byte. So if I make them add, so here 2 plus 1 is 3. So here 3 byte. So if somebody asks you what is the size of the structure employee, you should know that the size is 3. So here the size of structure is 3 byte, because here its elements are consuming the 3 bytes. So here the individual memory is allocated. So you can see that whenever we are creating the variable a of the structure employee, at that time a is having correspondingly 2 memories allocated, one for the g, and we know that g is a character, so it is consuming the 1 byte. And second memory we are having is c. We know that c is the integer, and integer consume 2 byte. Next thing in the structure is initialization, means providing the value to the structure elements. Initialize means providing the value. So here we know that we have already declared the structure variable, which is a, and correspondingly with the a we are having the 2 memory reserved, one for the character and one for the integer. Now for the initialization, first of all we are using the declaration part. We are saying that struct employee. We know that whenever we are using this struct employee, that combinedly making the signify that this is the user defined data type. Now the variable we have created is a. After that equal to curly bracket start. So here inside the curly bracket we are providing the values. First of all we know that we are having is the integer. So here integer value I am providing. Let's say it is 101. So here I am assuming that C is the code. So here 101 is the code. Now the second thing we are having is the character. So here let's say I am using that A. So this is called the initialization, means providing the value. So there 2 blocks are there where we are having is the values. Now we are having curly bracket start means initialize. So here 101. So 101 is going to the C, because here int C we have taken. So 101 will be going to the C. Then afterward A, we know that we are having the next thing is character, which is G. So here A is the character, which is the part of G now. So this is how we have initialized the values to the elements of structure. Now how to access structure element? So now we are learning that how to access the elements of structure. For accessing the elements of structure, we are having is the syntax. We know that first of all we have defined the structure by saying struct employee, then afterward int c char g. So here afterward we have created the structure variable, or we can say that we have declared the structure variable, that is A. And when we declare that, we are having the memories correspondingly which are reserved. So here G and C, they are reserved. So whenever you want to access the structure element, you have to go with the variable. We know that variable is A. So first of all we are taking the variable name. So variable name is A. So A we are taking. Then afterward dot we have to provide. So A dot member. We know that the members are C and D. So A can access the members. We know that whenever we define the A, we have the memories reserved for the G as well as C, which are the member of structure. So here we are saying the first member, and the first member is C. So A dot C. So to access the first member, we are saying A dot C. To access the second member, we can say that A dot G. So we are writing here A dot G. So this is how we can access the members of structure. If you want to initialize them, just like we have initialized before, that is perfectly possible. Let's say you are saying A dot C equal to, now here you are providing the value, that is 101. That is perfectly fine. And you are saying A dot G. So in the A dot G, if you are giving the A, so here that is perfectly fine. You understand that? This is also the other way of initialization. So this line and the above line both are same. So you can use any of the option, whatever you want. So by using A dot C and A dot G, A is the variable name and C and G are the members. By using A dot C and A dot G, you can take the input from the user by using the scanf statement, and you can provide the output to the user by saying printf statement. Let's say I'm using a printf statement here. So simply you can write printf. Printf means printing on the screen. Now afterward, we know that the first type we are having is the C. So here C is the integer. So for the integer we are taking is the %d. Now afterward, the second one we are having is the G, and G we know that is the character. So %C we are taking. Now comma, for %d, we know that here we are having the first thing, which is A dot C. A is the variable, C is the element, comma, then afterward we are having is A dot G. A is the variable, G is the element. So by using printf, we are printing on the screen. First we are saying A dot C. So here A is the variable of the structure, and corresponding to A, we are having the memory block, which is C, and C is of integer. So the value is 101. So the output of this one will be 101. Then afterward is A dot G. A is the structure variable, which is having the corresponding memory, that is G. G is a character. So here A, that A will be the output. So this is how we can access the structure elements. Now we are going to take one real life program. With the help of that, we will understand that how structure can be defined, declared, and initialized. So now we are learning this simple program of the structure. Then later we will modify this program to the little complex. So first of all, we are learning this. Here we are having is the first line, which is the comment. So that is a structure. Now this line is having no impact because this is the comment. Afterward, we are having is the hash include, which is a preprocessive directive. Then stdio.h, which is the file for the printf and scanf functions. Further, we are having is the void, means no return type. Main is the driving function. Inside that, we are going to define the structure. So first of all, we are using the struct. Struct is the keyword. Then employee. Employee is the name or the tag of the structure. Now this structure is having its body. So here, starting from the curly bracket till the end. So this is the body of the structure. Inside the body, we are having is the int code. One is the variable, which is code, that is of integer type. Then is the char name, 6. 6 is the size. That means it is the array. So we are having the name array, whose size is 6, that is of character type. So this complete thing is called the definition of structure. Now afterward we are saying struct employee. So here this is the complete user defined data type. Whenever we are having the system defined data type, just like integer, and for making its variable we write int a. Similarly here we are having the user defined data type, which is the struct employee, and its variable we are creating, that is a. So here a variable we are creating, that is of structure. Just like in the system defined data type, when we declare a variable, there is a memory which is reserved for the A. Let us suppose that there is a name A and the memory is 301. Similarly, when we are creating the variable of the structure, which is A, now here the memory will be reserved. Now what will be the memory? This A is the variable that is of employee. Structure employee have two further things. So here one portion is the code. So first element is the code, which is of integer type. So here corresponding to A, we are having one memory reserved with the name that is code. Now that code is having some memory, and that memory maybe have some address, let's say 501. And corresponding to A, we are having the second block reserved, which is the name. So here name is reserved, but inside the name we can see that it is the character array where the size is 6. So that means 6 block will be reserved. So here we are having the array of character. We know that character consume 1 byte. So let us suppose that the memory here start with 30. So here 30, 31, 32, 33, 34 and 35. So correspondingly 1 byte will be taken. So here we can see that the variable A contain 2 parts. One is the code and second one is the name. So here variable is declared. Now afterward we are having is the initialization. So afterward we are having is the curly bracket start till the curly bracket end. This is called the initialization of structure. Where we are having is the first element, which is 101. So we know that here the first element corresponding to A, that is code. So here code value will be 101. Now afterward we are having in the double quotes, that is Ankit. So here we are going to store that character by character ANKIT. So here we are dealing with the string because double quotes are applied. That's why at the last /0 null character will be applied. Now afterward we are having is the printf, means printing on the screen, %d, that is the integer. So here a dot code, we can see that A is the variable and variable is containing first element, which is code. So here A dot code, that means we are saying 101. So here 101 will be going from the %d. So the output will be 101. Now afterward A dot name, we know that A is the structure variable whose second part is name, and name is having the value which is Ankit. So here that is a string, that's why we are using the %s. So it is taking the value from A dot name. So here the output will be Ankit. So here 101 Ankit will be the output. So if somebody asks you the structure program, this is the easiest program of structure. But we know that structure is a user-defined data type. We can create more variables. Just like here we have created only one variable, we can create more variables. So I am modifying this program to the second variable. So we have modified this program. Here we have created one more variable of the structure. We know that already we are having is the struct employee. So whenever we are creating the variable of the structure, then we have to use struct employee because this is the user defined data type. Already we have discussed with the variable A. So afterward we are putting a comma and taking one more variable, which is B. Whenever we are dealing with the system defined data type, just like int, and we create the variable, so int A, then we provide its value, let's say 10, then afterward comma, we provide another variable, let's say B. In the similar manner, we are going to declare a variable B here. So here we can see that the struct employee, that is similar to the int, which is a system defined data type, and struct employee is a user defined data type. And there we have created the variable A. So that is exactly same as the variable declaration. Then we have provided its value. So here structure can contain multiple data type. So here multiple values can be taken, 101 and Ankit. But here in the system defined, we can take 10. Now afterward, we can declare more variables in the system, just like comma B. So similarly, here we are taking one more variable of structure, that is B. Whenever we are making the variable or declaring a variable of integer type, we know that there is one block reserved, which is having the B, and the memory may be, let's say, 401. Similarly, whenever we are making the variable of the structure, then here the blocks will be reserved. We know that here we are making the variable which is B, so the name of variable will be B, and this variable is of structure, and structure contain its elements. That means inside this B there will be further elements. The first element will be the code. We know that code is the integer data type, so here one block will be reserved. Let's say the address is 601, and then the second element is name. We know that this name is the character array, so correspondingly 6 block will be reserved. This name is of character type and character take only 1 byte. So that means let us suppose that the address first is 40. This is the base address. Then the next will be 41, 42, 43, 44 and 45. So this is how B is having 2 further things. One is code and second one is name. We know that the one way of initializing the structure is simply providing curly bracket, then afterward the 101 comma, here we provide Ankit. So this is one way. If you want to provide by using variable dot element, that is also fine. So here I am using the second way. I am using here B. So B is the variable. So B dot. Dot means going inside code. So here B dot code means we are going to access the block which is of code, and here we are saying 102. So inside the code we are providing value which is 102. Now afterward in the second line we are using the string copy function. You may think that we should provide variable name B. So B is the variable of structure dot. We should go with the name B dot name. Then afterward we should provide equal to and double quotes we should write Verma here. So that you may think, but understand whenever you are dealing with the string, because Verma is a string, so this type of declaration is not possible. Compiler will give you the error because B dot name equal to Verma. That is not possible. With the integer you can do that, just like B dot code we have done. Perfect. With the float you can do that, but with the integer this is invalid. That line is invalid. This is not possible. So for that we have to write the string function. For handling the string we are having the string function. So here we are having the string function which is strcpy. That means string copy. Copy the string. So here for using this function we need the header file. Just like for printf and scanf function we are having stdio.h. Similarly for string function, just like string compare or string copy, multiple functions are there. So for those functions we are having the header file which is hash include, which is a preprocessive directive including the string.h header file. So here strcpy is the string copy function which is the part of string.h header file. Now here the first element of that is where you want to copy, and second one is the value. So here we are saying that Verma should be copied to the B dot name. So by using string copy function we are saying copy the Verma to the B dot name. So what is going to happen? This is the perfect line. So this is the line where compiler will not show you the error. So you have to write this line, not this one. So B dot name equal to Verma is wrong, but here string copy is perfect. So we are doing that. So B dot name means B dot name. Here we are accessing the array and we are writing here VERMA. So Verma we are writing, then /0 null character will be applied. Now afterward we are going to display the value of the structure element. So we are saying printf means printing on the screen, /n for the new line. So here cursor is on to the next line. %d, that is for the integer value. So here b dot code. We know that here b is the structure variable which is having the first part which is code, and code value is 102. So here this value will be going to the %d. So here into the next line we are having the value which is 102. Now afterward we are having a %s, that is for the string. So b dot name. So here we know that b is the structure variable or the object, and it is having the second element, that is name. So here name we are having is the Verma. So here that name Verma is going and displaying with the help of %s. So here we are having is the Verma. So this is how we are having the output on the screen. So this is how we can define, declare and initialize the structure. So that is all about the structure.